All right, Unit 7, Day 3, we're talking today about the properties of logarithms. And so if you don't remember what logs are, you may need to review that a little bit before you look at this. So in class, in the notes, there's a few other things that I'm going to skip for the video. For the video, I'm just going to show you the rule and show you a couple practice problems. So this is the product property of logs. If you have the log of u times v, so like the u and the v are being multiplied together, that is exactly the same as the log of u plus the log of v. And whatever base you're in, the base just stays the same. So what we can do with this rule is we can do expansions. We could take a log if we have a log and expand it into a sum of two logs, or sometimes if we have two logs being added together, we condense it into one log. And again, whatever base you're in, the base stays the same. So we're going to first practice expanding the log of x times y. So we have a product, x times y, inside of our log. That would be exactly the same as the log of x plus the log of y. That next one, the natural log, so this is a base e log, the natural log of 9 times y is exactly the same as the natural log of 9 plus the natural log of y. The third one down, log base 2 of 8 times x, so we've got a product here. We can expand that to the log base 2 of 8 plus the log base 2 of x. And in fact, the log base 2 of 8, we can simplify it a little bit more. Remember, logs are asking you about what power you would use. Log base 2 of 8 is equal to the power of 2. That would give us a result of 8, so that is actually equal to 3. So this is 3 plus log base 2 of x. Last one, natural log of 7e. So we would have the natural log of 7 plus the natural log of e. Remember though, natural log of e is a base e logarithm, so this is the natural log with the base of e, so that's saying what power of e is e, and so this actually simplifies to 1. So it's the natural log of 7 plus 1, and that 7 is in the log, the plus 1 is not. You cannot add that to 8. This just has to be the natural log of 7. And then after you take the natural log of 7, then you add the 1. Okay, so that's expanding. We're not going to condense now. So it's essentially using that same rule, but we're going in the other direction. We're going to start with two logs added together, and we're going to condense it into a single logarithm. So in this case, it will be a log with base 2. Remember, whatever base you're in, it stays the same. And this will be x times y. Log base 6 of 12 plus log base 6 of 3, it's going to be a base 6 logarithm. And we're going to have our argument be 12 times 3, so it's 36. And then we actually could simplify that a little bit more. Log base 6 of 36 is essentially telling you what power of 6 is 36, and it's 6 to the second power, so that one simplifies to 2. Next one down, natural log of x plus the natural log of 5. Probably I would simplify this as the natural log of 5x. You could write the x first and then the 5, but it's more customary to do the coefficient 5 before the x. Next one down, log of 6 plus natural log of x. Here's our trick question of the day. We can't condense this because they are two different bases. Log log is base 10 and ln natural log is base e. So because these are different bases, we can't condense. Last one, log of 2 plus log of 7 plus log of x. Well, these logs are all being added, so we would, if we wanted to condense it, we would multiply their arguments. So this will be the log of 2 times 7 times x, which is the same as 14x. So that's our first log rule, sometimes called the product rule. The next log rule is about quotients. If you have the log of a quotient, sometimes you'll see it with parentheses here, sometimes you'll see it without. So if we have the log base b of u divided by v, that's the same thing as the log base b of u subtract the log base b of v. So subtraction of two logarithms is the log of the quotient. So that's why it's called the quotient rule. So again, bases have to be the same here, and we can both expand that and condense it. So first we're going to expand. The log of x divided by y is the same as the log of x subtract the log of y. The natural log of 9 over x is the same thing as the natural log of 9. Subtract the natural log of x. And the next one down is very, very similar, but it's a reciprocal here. It's the natural log of x over 9. So that means the natural log of x would come first, and we would subtract the natural log of 9. So the order really matters with division and subtraction. So make sure that you're getting it in the right order. And the last one in this column for expanding is the log base 5 of 25 over x. So we could expand that to a log base 5 of 25, and we're going to subtract log base 5 of x. And part of this we can simplify a little bit more. You should know that log base 5 of 25 is just a number. It's saying what power of 5 is 25, and that would be power 2. So this is like 2 minus the log base 5 of x. Same rule, but let's condense now. If we start with a log minus a log, it becomes the log of the quotient, x over y. Log base 6 of 72 minus log base 6 of 2 would be, since it's subtraction, it's going to be the log of the quotient. So log base 6 of 72 over 2. Well, that's the same as log base 6 of 36. And log base 6 of 36, 6 to the second power is 36. So that one simplifies just to the number 2. Natural log of 5, subtract the natural log of x. If we condense that, it would be the natural log of 5 over x. Last one, the log of 14x, subtract the log of 2. Well, if we use the quotient rule here, it will be the log of 14x divided by 2, which is the same as 7x. So that is some examples using the quotient rule. We have, sorry, I'm going to skip that. We have one last rule, and that is the power property of logs. So if you have a log that has an argument being raised to a power, that's the same as multiplying by the power the log of the argument. So this rule, I think, is usually the most tricky one for people at first. And again, we can both condense and expand this, and whatever base you're in, the base will stay the same. So let's look at some examples of this rule. Here is the log of x to the third power. Well, if we want to expand it, we bring that power down. So it's 3 times the log of x. And again, this whole let's bring the power down thing is only for logarithms. Don't start to confuse this with other things. It only works with logs. The natural log of 5 to the third power is the same as 3 times the natural log of 5. The natural log of e to the fifth power is the same as 5 times the natural log of e, but the natural log of e is just 1. That's saying what power of e is e. So this is the same as 5 times 1, which is just 5. Last one, we have the log base 5 of x to the negative 2 power. It's okay if that power is negative. We can still use this same rule. So that's log negative 2 times the log base 5 of x. So let's use that same rule and condense. So when we condense, we're basically going the other direction. If we have a number in front, a coefficient, we're going to bring that up as a power. So this will be the same as log base 2 of x to the 5th. This next one, that negative in front of the log, is sort of like a negative 1, so we're going to bring that power up. So it'll be log of 4 to the negative 1 power. Another way of writing that would be the log of 1/4. So negative exponent, remember, can be thought of as a reciprocal. 7 times the natural log of y. If we condense that, it would be the natural log of y to the 7th. 1/3 the log of x. We could bring that up as the log of x to the 1/3 power. Now, fractional powers can be thought of as roots, so that would be the same, if you wanted, as the log of the cube root of x, but don't panic if you don't get that. It would be fine to write log of x to the 1/3 as well. Okay, so that is the power property of logarithms. So here's all three of the rules together. So if two logs are added together, it's the log of the product. If two logs are subtracted, it's the log of the quotient. And if you have a multiple, a coefficient there, it can be a power of the argument. So we're going to use these rules together now, and as you look at each one of these, you'll have to decide which rule to use. So the first one, we're going to expand first. So log of x to the 6th power, if I'm expanding that, I see this power 6, and I bring that down. So 6 log x. Log of 6 times x was going to use the product rule, so it'll be the log of 6 plus the log of x. And log of x over 6, we'll use the quotient rule. Log of x, subtract the log of 6. So those three all had 6's and x's, so it's kind of, I think, nice to look and see what the difference between all of those are. The next one, natural log of 3 times x. This is the product rule, so it's the natural log of 3 plus the natural log of x. The log base 3 of x over 3 is going to use the quotient rule. The log base 3 of x, subtract the log base 3 of 3. Hopefully you recognize log base 3 of 3 as being equal to 1. So this is the log base 3 of x, subtract 1. Next one is also a quotient rule. We have the log base 2 of 4, subtract the log base 2 of 7. And maybe you recognize this quantity here, log base 2 of 4 is the same as the number 2. So it's 2 minus log base 2 of 7. Natural log of y to the 4th power, we're going to bring that power down. 4 times the log, natural log of y. Log of the square root of x, so you need to remember that that is the same as the log of x to the 1/2 power. A square root is the same as a 1/2 power. So we can bring that power down to when we expand, and it'll be 1/2 the log of x. Last one, we have the log of x times y times z. We'll use our product rule here. It's the log of x plus the log of y plus the log of z, and they are all base 9. So there we are expanding, and they're kind of mixed together, so you have to decide which of the rules that you have. Now let's switch to condensing. Same thing, we're going to use all three rules. We just want to condense each expression, and as you're looking at each one, you'll have to decide which rule to use. So here we have a log plus a log. So it's going to be the log base 2, of course, of 5x. Multiply that 5 and that x together. We're going to condense this, and when we condense, if we have those coefficients, we want that to become a power. Log base 2 of x to the 5th power. And this last one on the top row is subtraction. Subtraction of two logs becomes the log of a quotient. So it's the log base 2 of 5 over x. If you want, you can put parentheses around that, or you don't have to. Either way, whichever one looks the best to you. The natural log of y minus the natural log of 7 is subtraction. So when we condense that, it's going to be the natural log of y over 7. The natural log of 7 minus the natural log of y. Again, it's the quotient rule, but this time it's the natural log of 7 over y. Next one over, 1/3, the log of b. This is base 10. We can bring this coefficient up as a power, so that would be log of b to the 1/3 power. Another way to write that, if you want, would be the log of the cube root of b. Remember that if you have a root, it's the same as a 1 over that index power. So the 1 over nth power is the nth root. You could write that one as the 1/3 power 2, that's fine. Okay, so we've got a log base 3 of a plus the log base 3 of c. That would be our product rule, log base 3 of ac. This next one over, we again have some addition. So this would be the log of x times y times z. Last one, we've got a power rule here. We're going to bring that exponent up. Another way of writing this, if you wanted, would be the natural log of 1 over x squared. Sometimes people confuse those two rules, the rule with the fraction exponent and the rule with the negative exponent. So I'll write that on the next slide so you can see the difference. If we have x to the 1 over n, that's the same as the nth root of x. If we have x to the negative n, that's the same as a 1 over x to the n. Two very different things, but sometimes people get them mixed up. Anyway, that's it. We're just practicing those basic rules today. Next time we're practicing a little bit more complicated version of the rules, but it's the same rules. If you have questions, come in and ask me, and I will hopefully get you squared away. Thanks.